It's green as 5 Maths 2016 paper 1 question 1 on vectors. Given that p is 4, -6 and q is -5, -1, find half p plus q. Give your answer in component form, which is this form. Okay, so let's do a half of p plus q. So that is going to be a half of 4 minus 6 is p plus -5 minus 1. So that equals, we can just half the numbers. That's 2 minus 3 plus -5 minus 1. Add the top, 2 plus -5 is -3. -3 plus -1 is -4. And we're done there. -3 -4 is our answer. Okay, 2016 paper 1 question 2. 3/4 brackets a third plus 2/7. So BidMaths gets involved here. I do the bits inside the brackets first, then I times the bit outside. So the first thing I'm going to do is a third plus 2/7. Common denominator is 21, 3 times 7. 1 times 7 is 7, plus 2 times 3 is 6. 7 plus 6 is 13, so we get 13 out of 21. We've got 3/4 times the answer we just got, 13 out of 21. Now, at this stage, you can simplify after you do the times or before. You can always simplify with a times, but you can't do it with an add for fractions. So here we go. We can simplify by dividing by 3 to get 1, divide by 3 to get 7. Now the sum becomes a lot easier. So that means we've got 1 times 13, and we've got 4/7 is 28. 13 out of 28. Just double check if there was any more simplification I can do. I know there isn't, but there's no numbers that go into 13 and 28, so I'm done.
SQA National 5 Maths 2016 paper 1 question 3 for area of a sector. The diagram shows a sector of a circle, centre C, and the radius is 20, the angle is 45. Calculate the area of a sector without a calculator. So we'll start off with the same way. Area equals angle out of 360 times pi r squared, and we calculate that by putting 45 out of 360 times pi times 20 squared. 2 marks so far, 1 mark for getting the fraction and 1 mark for substituting in, and now we just need to do lots of work to get the actual answer for our final mark. So fractions we simplify, so 45 into 360, well 45 goes into 360 8 times, so I get 1/8 times pi. 20 times 20 is 400, so I do an 8 of 400 is 50 times pi, and then again you can just at the side do 3.14 times 5. 5 4s is 20, 5 1s is 5 plus 2 is 7, 5 3s is 15. You get 15.70, so that gives you, that's times by 5, so it's 10 times 15.70, which is 157 centimetres squared for our final answer. Another quick way at this point would be to times by 100 and then divide by 2.
It's been National 5 Maths 2016 paper 1 question 4 on simultaneous equations. Charlie is making costumes for a school show. One day he made 2 cloaks and 3 dresses, and the amount of material used was 9.6 square meters. Write down an equation to illustrate this information. Standard stuff. 2 cloaks, let's call that 2C, plus 3 dresses, 3D, equals 9.6, because it's 9.6 square meters, and there's an easy mark. Part B says the following day Charlie made 3 cloaks, and 4 dresses, plus 4 dresses, and the amount of material used was 13.3, equals 13.3. I've now written the equation to illustrate that information for another mark. Calculate the amount of material required to make 1 cloak and the amount to make 1 dress for part C. So simultaneous equations. So I write my equations top and bottom of each other. So I'm going to write this one first, I think, the big one, 3C plus 4D equals 13.3, and I'm going to write a smaller one underneath, but it doesn't matter, it just makes it easier to see. So 2C plus 3D equals 9.6. And the game here is to either get the C is the same or the D is the same. I'm just going to make the D's the same. So I'm going to times this one by 3 to give 12. And I'm going to times this one by 4 to give 12 again. So times them by 3 and times them by 4. So this is non-calculator, so just being careful with your sums. 3 times 3 is 9c plus 3 times 4 is 12d. And if you have to do a sum at the side, you can, but 3 threes is 9. 3 threes is 9. 3 ones is 3. So I get 39.9. Bottom one, 4 twos are 8c. 4 threes are 12d. And then again, 4 times 6 is 24. So that's 4, carry the 2. 4 times 9 is 36, 37, 38. So I get 38.4. Now, these are now the same. If the sign in front of them is the same, we take away. If the sign's a different, we add. So I'm going to take away. So let's do that here. 9 minus 8 is 1c. They disappear. Equals, I need to do 39.9 minus 38.4. So 9 minus 4 is 5. 9 minus 8 is 1. 3 minus 3 is 0. C is 1.5. I'll just line that there. And then to find D, we substitute into any equation. So let's start off with one of the easier ones. The smallest one there, 9.6, 2c plus 3d, but you can pick any one. So I've got 2 times c, 1.5, plus 3d equals 9.6. That gives me 3 plus 3d is 9.6. So taking away 3 for both sides, you can note that there if you want. We get 3d equals 9876.6, and that means that d divided by 3 is 2.2. Now, we are not finished. You cannot just leave your answer C is 1.5 and D is 2.2. It says find the amount of material required to make a cloak and whatever it was, dress. So I need to write that down. So I can just write at the side, cloak equals 1.5. And what's the units? Square meters. So meters squared of material. And dress equals 2.2 meters squared of material. And that's just to get my final answer by writing my answer in context of the question. That's 5 Maths 2016, paper 1, question 5 on line of best fit. A cattle farmer records the weight of some of his calves. The scatter graph shows the relationship between the age, months, and the weight in kilograms of the calves. So weight up top, age on the side. Line of best fit is shown. Point D is a 3-month-old calf and weighs 100 kilos. Point E is 15 months and 340. Find the equation of a line of best fit. So this is straight line in context, where all we've done is change that Y to W and X to A. So it's still the same idea. We need to find 2 points to find the gradient. Then use Y equals mx plus C, or Y minus B is mx minus A. I use the second one usually. So there's my point D, there, and E. So let's write down the 2 points to start with. D is 3/100. It tells me here. E is 15/340. That tells me there. So I can find the gradient. Remember, gradient is y2 minus y1 over x2 minus x1. So I call one of them x1 and y1, and the other one x2 and y2. I usually make the bigger one x2, y2. Subbing it in, 340 minus 100 over 15 minus 3. That's 240 on the top and 12 on the bottom. 12 goes into 24 twice, so that makes 20 as my gradient. So now the second step is to use y minus b equals mx minus a. That's the way I always do it, so I'm going to not stop there. A and b is just one of the points, so I always use any one, but the small one's easier. A and b. So a is 3, b is 100. Y minus 100 equals m, which is 20, x minus 3. Expanding my bracket then, y minus 100 equals 20x. 20 times 3 is 60, so minus 60. It says minus 100 on this side, so if I add 100 to the other side, I'll have y on its own. So y equals 20x. 100 minus 60 is plus 40. And usually I'd be done there with straight line, but now we need to look at what it's telling us in the question. It's w and a. So I write w for y equals 20a for x plus 40, and that's part A done for all our marks. Part B, use your equation for part A to estimate the weight of a 1-year-old calf. So let's see what A and W represented. W is weight in kilograms, age is months. Oh, we're trying to trick us here. 1-year-old means A equals 12 because age is in months. So W equals 20 times 12 plus 40. 20 times 12, well, I'll do 20 times 10 is 200. 20 times 2 is 40, so that gives you 240 plus 40, which is 280 kilograms. And we're done there. It's great. National 5 Maths 2016 paper 1 question 6. Determine the nature of the roots of the function 7x squared plus 5x minus 1. So nature of the roots is the discriminant. You can find the formula for quadratic formula at the start of the exam paper, and it's a bit that says b squared minus 4ac. So I want to look at b squared minus 4ac. So a is 7, b is 5, and c is minus 1. So summing that in, we get 5 squared minus 4 times 7 times minus 1. That gives me 25. 4 sevens is 28, but a minus times a minus is a plus. So it's plus 28. Be careful of that. Now I need to do 25 plus 28. Well, that is 53. And then we need a statement. So there's 3 options. If b squared minus 4ac is positive, it's got 2 real and distinct roots. If it's equal to 0, it's got 2 real and equal roots, or 1 real and equal root. And if it's negative, it's got no real roots. So since b squared minus 4ac is greater than 0, it has 2 real and distinct roots. And we're done there. It's Green National 5 Maths 2016 paper 1 question 7 on 3D coordinates. The diagram below shows a rectangular base pyramid relative to the coordinate axis. A is 2, 0, 0, shown in the diagram. And we've got V is 5, 2, 6, which is in the middle, so we're going to use that fact. And we have to write down the coordinates of B. So we can see B is way over there. And how these work is you go along the X, then up the Y, and then up the Z. So X, Y, Z. So let's start from A. It goes 2. If I jump along to here, I'm in the middle, which is 5. I've went along 3, so I can jump out another 3, 5, 6, 7, 8. So I know the first number is 8. Now we move to the next number. Well, I'm now here. I need to go all the way up here. We need to check how long is that. Well, we know that because the distance from here to here is 2. Another 2 makes 4. So I'm going along 4. So I write 4 down. And then the last step is I've went along and in, and then I'm actually already there. So I'm not moving up or down or moving anywhere at all now. So that's just 0. 8, 4, 0, and we're done there. Part B says calculate the length of the edge AV of the pyramid. Now this is 3D Pythagoras at this point. We've got the length AV goes from here to here. So we've got this kind of base here. If I look at this triangle, it goes down, and it's at right angles to here, and then I need to go up here. So there's a picture to illustrate this point A to V. Now we need to know this line here, but that can be done by Pythagoras because it's 3 along here and it's 2 along there, 3 squared plus 2 squared. So I can write that that is 3 squared plus 2 squared, and then the height of the pyramid is 6 because it starts from the bottom and goes up 6. So it's 6 squared. So therefore, 3D Pythagoras, 3 numbers, the length of AV is equal to the square root of 3 squared plus 2 squared plus 6 squared. Well, that is the square root of 9 plus 4 plus 36. That equals the square root of 49. Take your time on that. And the square root of 49 is 7. So it's 7 units. And we're done there. Okay, solving equations. Let's look at some past papers on this. 2016 paper 1 question 8 said solve this equation, give your answer in the simplest form. So we've got fractions, so we need to deal with those fractions. The easiest way to deal with them is to get rid of them by times and by the lowest common multiple of the denominators. So if we look at the denominators here, we've got 3 and 6. The lowest common multiple between them is 6, so I times everything by 6. That's this one, and this one. So we've got 6 times 2x over 3 minus 6 times 5 over 6 equals 6 times 2x. Now we can just simplify everything as we go. So 6 divided by 3 is 2, so that gives me 2 times 2x. 6 divided by 6 is 1, so that gives me minus 5. And 6 times 2 is 12, so that gives me 12x. Now we can work out this by solving the equation. 2 2s is 4, 4x minus 5 equals 12x. Take the 4x to the other side, we get minus 5 equals 12 minus 4 is 8x. And therefore, x equals minus 5 over 8 for our final answer. The next question says, a function f of x is defined as f of x is 2 over root x. Express f of 5 as a fraction with a rational denominator. So we're coming in with surds here, but we're still the same point for part 1 for 1 mark. All you have to write is f of 5 equals 2 over root 5. And then working that out with surds, times the top and bottom by root 5. To rationalise the denominator, we get 2 root 5 on the top over 5 on the bottom, and that is as simple as it's going to get. So we're completing the square and parabolas. SQA National 5 Maths 2016, paper 1, question 10. Sketch the graph of y equals x minus 3 squared plus 1. Show clearly the coordinates of the turning point and intersection of the y-axis. Well, the turning point is easy. TP, turning point. It is simply the opposite of this number, which is 3, the opposite sign, and then the second number 1. Why is it the opposite? Because it's what makes this 0. 3 take away 3 is nothing. Okay, where it cuts the y-axis. Cuts the y-axis when the other letter x equals 0. So just subbing that in, we get y equals 0 minus 3 squared plus 1. That's minus 3 squared plus 1. 9 plus 1 is 10. So the point is 0, 10. Or you can remember that you just do that squared plus that, always when it's in completely square form to get where it cuts the y-axis. So now we can just draw a little picture. An x and y-axis, it's just a little sketch. So we're going to cut at 10, so I'll just note that. And our turning point is 3, 1. So we can go 3, along 3, up 1, say, is there, and then just draw a nice, neat parabola and label that point nice and neatly 3, 1, and we're done there.
Okay, 2016 National 5 Maths paper 1 question 11 said simplify tan squared x equals tan squared x cos squared x. So we've got tan and cos squared, so we can change the tan into sine over cos. So step 1, sine squared x over cos squared x. Right, because that's my tan squared x, and I'm timesing that by cos squared x. So you get a mark for getting sine over cos or sine squared over cos squared. And then for simplifying that, well, the cos squareds cancel out. So we get our final mark for getting sine squared x. And we're done there. And it says the diagrams below show a rectangle and triangle. All measurements are in centimetres. Find an expression for the area of a rectangle for 1 mark. Then, given the area of a rectangle equals the area of a triangle, show that x squared minus 2x minus 8 equals 0 for 3 marks. Then find algebraically the length and breadth of a rectangle for 3 marks as well. Have a look at this and see if you can get anywhere with it before we come back and discuss it and see what the solution is. Okay, so what this question is asked us to do is find an expression for the area of a rectangle, which we'll do in a moment, but essentially it turns into a quadratic question, but also it is going to be, you're going to have to find the expression for the triangle, make them equal to each other, and then rearrange that equation to get that quadratic. Quite a hard skill. Once you've done that, you'll then have to solve your quadratic equation. I'm going to go through a few steps with this and a few pointers that I think might make this a little bit easier, especially if you can't do the whole question. Okay, part A, find an expression for the area of a rectangle. Don't be scared by this. You all know the area of a rectangle is length times breadth. So just write down what the length of the rectangle is. If it was a number, you would write down 4, 5, 6. But in this case, it's x plus 8. So I'll just write down x plus 8. Now, since this is going to be times by something else, I'll put that in brackets. And I need to times by the breadth for the height, which is 2x plus 1. 2x plus 1. So there is an expression for the area of my rectangle for 1 mark. Part B, given that the area of a rectangle equals the area of a triangle, show that this. Now, we'll try to get there, but we don't know how to get there. But it does say area of rectangle equal area of triangle. So we know the area of a rectangle is x plus 8 and 2x plus 1. And that equals the area of a triangle. Well, a triangle is half times the base, 2x plus 5, times the height, 3x. So we can write they equal to each other. So now we need to expand some brackets, and we'll get marks for expanding the brackets if I've managed to write this down. So expanding the left-hand side, I usually use a box. We get x plus 8 on one side and 2x plus 1 on the other side to get 2x squared plus 16x plus 1x plus 8. And that equals a half times 2 is 1. So that's 3x times 1 times x plus 5. So essentially it's a half times 2 is 1. Even just this to expand. That gives me 3x squared plus 15x. Tidying up the left-hand side, we get 2x squared plus 17x plus 8. And that equals the right-hand side of 3x squared plus 15x. You would get a mark for expanding this bracket and a mark for expanding that bracket. And then a mark for making them equal to each other and then somehow getting it down to the expression that they want. Now, the expression they want is equal to 0, so I need to move everything over to the same side. So I've got small 2x squared, so if I look at the right-hand side, I've got 3x squared plus 15x. I'm going to make this 0. I'm going to take away 2x squared then. I'm going to take away 17x, and I'm going to take away 8. So 0 equals 3x squared minus 2x squared, which is x squared. 15x minus 17x is minus 2x, and I've got minus 8. Or to put it in the way they want, x squared minus 2x minus 8 equals 0. Now, you couldn't get very far with this question if you couldn't do part A. And if you could even do part A, but you couldn't write down an expression for the triangle, or just didn't know what to do, you couldn't do part B. That doesn't stop you doing part C though, because part C then says, hence find algebraic with length and breadth of the rectangle. And the question already told you that x squared minus 2x minus 8 equals 0 in part B. So even if you've lost the first two parts, you can still, if you know how to factorise and find out x, work out this from using quadratics. Okay, so you either got a quadratic formula or you've got factorising. Now, since this is non-calculator, you can bet 9 times out of 10 we're going to factorise. So let's have a look at it. We have got x squared minus 8x, 2x minus 8 equals 0. You're looking for, just to factorise this, numbers that times together to make 8. So I've got 1 and 8 or 2 and 4. And I want to pick the pair that add or take away to make minus 2. Well, 1 and 8 never does it, so it's going to have to be 2 and 4. And then I just write down, how does that make minus 2? Well, it makes minus 2 by doing, it's not going to be 4 take away 2 because that's plus 2. It's going to be 2 take away 4. Or plus 2 take away 4 is minus 2. And plus 2 times minus 4, just to check, is minus 8, which is the last number. So I can now factorise it. And a lot of this you could have done without any working. X and x. I've got plus 2 in one bracket and minus 4 in the other. You get a mark for factorising. And then for solving, you can then say x plus 2 equals 0 or x minus 4 equals 0. So that gives me that x equals minus 2 or x equals 4 for a second mark. And then, because this is a question in context and we're talking about actual lengths of the triangle and rectangle, if we go back up and look at the lengths, we've got x add 8 on the rectangle. Well, that means that we've got 4 plus 8 and we've got minus 2 add 8. And then on the other side, we've got 2x add 1. So that's 2 times 4 is 8 plus 1 is 9. But then you'd have, if you use the minus 1, minus 2 plus 1. Minus 2 times 2 is minus 4 plus 1, which is minus 5. So we can't have a negative x because it's going to give us a negative height or breadth, and that doesn't work. We can't have a negative length. So we have to pick the one that's going to work. So using x equal to 4, the length is equal to, so remember back at our triangle, 8 plus 4, which is 12 centimetres. If the breadth was 2x add 1, so 2 times 4 plus 1, which is 9 centimetres. And we get our final mark for working that out.